This video lecture is a walkthrough of heat exercise part 1, looking at calculating mortality rates and relative risks. This is for GPH 301, Intro to Quantitative Geography. Hopefully you've had a chance to watch the first video, which went over the basic context of looking at risk and chances of death or illness, and also the specific risk of heat. In this video, we're going to look specifically at how we begin the calculations that are due for the exercises themselves. So, as before, the exercise is available in Canvas. Part 1 through 3 is a separate quiz. The PDF document, though, covers all the exercises that we're going to do regarding heat. That PDF document, which you can download here, gives some context and explains different concepts that we're going to use, and then later on provides the exact steps to do the analyses. So if you want to go back to it, it is a resource available to you. In addition, we have the Excel workbook that we're going to use to do the actual exercises, which is what we're going to work on now. So if we open up that exercise, or that workbook rather, what we have are in the first tab or sheet, data that comes from the Centers for Disease Control, which is the lead agency in the U.S. for collecting statistics on morbidity and mortality, or illness and death. And this specific data came from a research article done by some CDC researchers, actually. We have data from 1999 to 2014. We have here in our columns then total population in those years. So we can see in 1999 there were 279 million people or so in the U.S., and in 2014 it had risen to over 318 million. And today it's a little over 330 million, but we're only going to work through 2014 here. We have separately the counts for subpopulations, like the population in 65 years and older. So we can see that in 1999 they were about 34.5 million people in the population. And then we have non-Hispanic white population, or the white population, the non-white or minority population, and then specifically the non-Hispanic black population or African American population. So we're going to work with these as our denominators. So these are going to provide the basis of comparison, or in terms of understanding, what portion of the population was affected, but also to calculate our rates. What we're interested in here is death, mortality, and we have here numbers of all-cause deaths, meaning that any cause of death that was counted. So we can see in 1999 there were about 2.3, almost 2.4 million people who died that year. In 2014, it was about 2.6 million people who died, so more people. But of course, we should expect, right, since the population grew, that's not terribly surprising. The nice thing is when we convert to rates, it accounts for that, right? It controls for different size populations. We also have the deaths that are cause-specific deaths, right? So in this case, the number of people that year who died from heat. So in 1999, that was 302 people, and it fluctuated a bit and was relatively low in 2014 with only 44 people. So as a cause of death, it's a relatively small, it is a very small proportion of all deaths, right? The ones caused by heat, but nevertheless, that's what we're looking at. We can break that down further by looking at the cause-specific deaths for different groups, looking at, again, at those same subgroups of interest, people 65 and older, whites, non-whites or minorities, and then non-Hispanic blacks. So we see these are just total counts, right? The numbers of people, the absolute numbers who died. So we're going to calculate rates, and we're going to be using a lot of the numbers that are here in the subpopulation numbers, and so we're going to be jumping back and forth a little bit. So I'm going to freeze the sheet a bit so I can keep the numbers stable, and so you can do that in a couple ways. The simplest way is to just freeze that first column, and so we've done this before. So where it says freeze panes under the view menu, you can freeze that first column. And when you do that, you might notice a little gray line appears. So when we scroll to the right, we don't lose those years. And that helps us kind of keep track of what we're looking at. But we're still going to have, just to warn you, we're going to have to jump back and forth when we build our formulas. So the first thing we're going to construct is the all-cause mortality or death rate per million people. So we're going to say this is the crude, and all these deaths, the crude death rate per million people, right? So the crude death rate per million, when we do death rates, they're a lot like proportions or percentages. We take the number of people who died and we divide it by the number of people who were alive that year, right? Assuming they were all equally at risk of dying, or they can die at least. And then, though, what's different in a rate is we multiply that proportion by a particular number, and it can be any choice we want. We're picking 1 million here because it's a common unit to use as a point of comparison. Well, let's do one so we can see what it looks like. So we're going to calculate the crude death rate per million people in 1999, right? So we start off like with any other formula with the equal sign, and then we want to take the number of people who died in that year, right? The total population who died. So that's this number right here in cell G8. And then we're going to divide that. I'm working up here my formula bar, so I'm not jumping around too much. Divide that by the total population, assuming they were all equally at risk. Now, at that point, just taking the people who died divided by the people who were alive that year, or the population, will just give us a proportion. So what proportion of the population died that year. But to make it a rate, we have to multiply it by 1 million. So in this case, we'll do, instead of writing out 1 million, we'll write 10 to the power of 6, or 10 to the 6, which is 1 million, because it's easier to write that way. And that's it. So I hit enter, and then I jump over here to my formula on the far right, and I can see my value. And let me get rid of those decimal places because we don't have that level of precision. All right, so what that means is that in 1999, the crude death rate in the U.S. was 8,570 per million people. So that means that let's say in a city of 1 million people that year, you should have expected about 8,500 or so of them to die. And that would be normal. That would be pretty consistent with what's been going on. Now, the per million part allows us to compare between different places, say between different cities, but it also allows us to compare over time. So we noticed before that more people died in 2014 than 1999, and we suspect that has something to do with the fact that the population was larger. And so the rate controls for that. So if we copy that formula down, which is really simple, right? We just drag that little green square in the lower right down, we can calculate the rates for each year. And so what we see is that it bounces around a little bit, but in general it tends to go down. So that by the time we get to 2014, the death rate for the U.S. population is actually lower. So even though it's a larger population, when you take that into account, you actually have a lower death rate. Right? And again, the crude death rate, the purpose of doing it this way is, again, for comparison. Right? And usually that is a common thing that you're doing over time. Now, each death rate is actually computed for that specific year. And so that's important. If you wanted to know what the crude death rate was for that time period, the period between 1999 and 2014, you have to do it in a very specific way. You could take the average of all these numbers, but that's actually going to be misleading, right? Now, I can obviously compute that, right? I could type equals average and then take all those values and compute that, right? And if I do it that way, I get that number, right? So the average crude death rate over that time period was 8,242 per million. Now, the problem with that number is that it doesn't take into account the different sizes of the population. So what do I mean by that? Well, there were simply more people in the U.S. in 2014 than in 1999, right? We know that. Well, when you take an average of these rates, the rates themselves have already been adjusted for the different population sizes. So what it means is that the fewer people that were there in 1999 can account for more than they should in 2014. You want a number that takes into account the different size populations that you're comparing. So the appropriate way to do it is not to take an average, but rather to compute the rate by adding up the populations and the deaths over this time period. So what that looks like is this. We start a formula, and it's structured the exact same way. The numerator, the top part of the fraction that we're calculating here, is the number of people who died, right? So we're not using 1 year, we're using all the years. So in order to do that, we're going to take the sum of the deaths for all those years. So what that means, I'm starting with a sum formula. I'm going to take all the deaths from 1999 to 2014, add them all up. And then I'm going to divide the sum of all the population numbers for the same time periods. I'm going to scroll to the left here and highlight all of the population numbers for the same time period. Now I'm going to move up to the formula bar so I can complete it without jumping around. Closing off that. So again, the structure of the formula is the exact same thing. Numerator is number of people who died divided by the denominator, the number of people who were alive in that time period. And then finally, like with all the rates we're doing here, you multiply by 1,000,000, 10 to the 6th, right? So when I hit enter, I get my value. So that number right there, 8,236, is slightly different than the average we got earlier, represents the crude death rate per million for the whole time period, right? And again, the emphasis is that the rates are always time specific, so they don't necessarily apply all the time. So what we're going to do here is I want to calculate the cause specific death rates from heat. So we can do the same thing like we did with the crude death rate, the total death rate. We can say we want to know the crude heat-related death rate per million. Right? So it works exactly the same way. And this time, instead of taking the total number of deaths, we want to get the number of people who died from heat specifically, right? So we start the formula and we select the heat-related deaths, right? And I'll move up here to the formula bar again and divide it by the total population, just like we did before. And then finally, we multiply again by 1,000,000. So that's the same thing, right? The only thing that changed there was that we wanted to know this particular kinds of deaths, right? But the underlying population didn't change. It's still the total population who are technically subject to that, right? So this number devolves to 1, but I know that's not right. So this one I do need decimal places because these are smaller numbers. I'm going to expand the number of decimal places to 2. Copy that down. And I can see then that these are very small numbers, right, in comparison to the total. And that's not surprising because there aren't a lot of people that died from that particularly, right? And again, we can do the heat-related death rate per million for the whole time period like we did for the total death rate by summing up the deaths and summing up the total populations over that time period. I'm going to let you do that, though. Okay. Now, we are interested, though, in comparing groups, right, to see how this varies by group. So I want to know what is the heat-related death rate per million for people 65 and over, right? And how does that compare to the general population? So the way I do that is I start, well, let me give it a title first, of course. So I want to say the crude heat-related death rate for 65 plus per million. I know it's kind of a lot there, but it's important to be clear about what it is you're doing there. Okay, so I want to know for that age group, what is the death rate from heat? So I start the formula off the way I always do with equal sign, and I want to take the numerator, which is always the number of people who died. So we're looking at that particular group. So we're looking in the I column to see how many people 65 and over died from heat that year. And then we're dividing it by the population. Now here we have to be careful, right? You can't die from heat you can't be someone who died from heat at 65 and older unless you were 65 and older, right? So the population that's at risk has to be the population who are 65 and older. So rather than using the total population, we're using the population who are 65 plus, right? So that's really important, is to use the proper denominator, the proper population comparison. But once you got that, the last bit's the same. You multiply again by 1,000,000, right? 10 to the 6th. And we hit enter, and we get our value. So we see that, this is interesting. So in 1999, the death rate from heat for people 65 and over was 5.98 per million, which, notice, is a lot higher than the same rate for the general population. And that's an important observation. Well, let's copy this down first. So we'll drag this down, copy the formula to the remaining cells. Right? We can see how it changes over time. It actually goes down, which is great, right? But notice that it stays consistently higher than the general population. And this is kind of where the value of the rates comes into play here, because it allows us to say, okay, this is actually really different, right? Now, one way that we can communicate that difference is by calculating what's called a relative risk. And the relative risk is a way of comparing two different populations to understand how much more at risk one is compared to another or relative to another. So the relative risk of heat-related mortality for 65 plus, okay, is essentially the ratio of their risk or their death rate from that to the death rate for the general population. So what does that mean? Well, it's actually really simple. In this case, you're dividing one number by the other. That's pretty much it. So in this case, if we want to compare people 65 and over to the general population, we take their number, right, their death rate from heat, and we divide it by the death rate from heat for the general population. And that's it. You just divide one number by the other. The key thing is that the number on top, the numerator, is the population that you want to find out about. So when I hit enter, the number that I get there, let me reduce the number of decimal places because that's distracting. That number right there represents how much more at risk this population is. And specifically, the way that I read that number is people who are 65 years and older are 5.5 times more likely to die from heat than the general population. At least they were in 1999. Okay, 5.5 times more likely to have died from that. Now I can copy it down to the remaining cells, and I can see, oops, almost the last one. We can see that the population 65 years and older are consistently more at risk of dying from heat than the general population, right? And that's important because it tells us that that group is a high-risk group, which is what we've suspected, but this is what communicates that difference in risk. So then what we have is a real quick way of describing that difference in risk, right? Literally is this many times more likely to die from that particular cause. So what I want you to do, and I'm not going to do it here, you're going to repeat these calculations, right? Calculating the death rate from heat for the different groups, and then I want you to calculate the relative risk of those other subgroups compared to the general population. So looking at the white population compared to the general population, the minority, and then the non-Hispanic black population. And what we're looking for is to understand the difference in risk amongst those groups and how we communicate those. All right, so there you go.